Welcome again to Math 800 Pre-Algebra. Today we are doing section 2.1, Introduction to Variables. Our objectives: 1. To identify variables, constants, and expressions. 2. To evaluate variable expressions for given replacement values. 3. To write properties of operations using variables. And 4. Use exponents with variables. Objective 1. Identify variables, constants, and expressions. A variable is a letter that represents a quantity that varies. A constant is a quantity that does not change. So if you are doing a problem and one of the things in the problem can change, you use a letter or a variable to represent it. If you're doing a problem and a number never changes, it is constant. Here is an example of an expression. The c is the variable, or the part of the rule that varies or changes. The 5 is the constant, or the part of the rule that does not change. Objective 2. Evaluate variable expressions for given replacement values. Suppose the expression c minus 10 represents the number of books a bookstore will order based on the class limit c. Evaluate the expression when the class limit is 32. Our expression is c minus 10. In this case, we're going to replace c with 32 because the problem says the class limit is 32, and we were told that c is the class limit. Replace c with 32. Now we will just follow the rule and subtract 32 minus 10, and 32 minus 10 is 22, so the bookstore will order 22 books. Notice how your final answer should be written as a sentence. You must have units. If you don't have units, you will lose points. I would encourage you to write a complete sentence. That way you make sure you have units. The number part in a multiplication expression is called the coefficient. So in this expression we have 4 times s. The 4, the thing that we're multiplying by, is the coefficient. The s is the variable. Be careful. If an expression involves adding, subtracting, or dividing, then you do have to write the plus, minus, or division sign. It is only multiplication that is understood without writing an operation symbol. For example, the 4 plus the s, you have to write the plus. 4 minus s, you have to write the minus. And 4 divided by s, you have to write the division. However, 4 times s, we don't write any symbol. If you just see a number next to a letter, it is multiplication. Notice in this case, this would be the coefficient. However, here, these would be constants. So when you're multiplying, the number in front that you're multiplying with is a coefficient. If you're adding or subtracting, the number is a constant. The expression 100 plus a divided by 2 can be used to approximate systolic blood pressure of a person that is 8 years old. Evaluate the expression for a person that is 24. The expression was 100 plus a divided by 2. We're replacing a with 24 because that is the age of the person. Let's replace the a with the 24. Now we will follow the rule using the order of operations. First, divide 24 divided by 2. Division must happen before addition. 24 divided by 2 is 12. Now we will add. 100 plus 12 is 112. So the approximate systolic blood pressure is 112. Notice again the answer is written as a complete sentence. Consider the expression below for finding your average bowling score. Find your average score if you bowl 3 games and your total score is 378. So the expression is t, which is the total score for all games, it is a variable, divided by g, which is the number of games, which is also a variable. Many expressions involve more than one variable. This is true in math as well as business, science, economics, and many other subjects. Many of your expressions will have multiple variables. In this case, t, which was your total score, was 378. So you replace t with 378. G was the number of games, and we bowled 3 games, so you replace it with 3. And now we follow the rule and divide 378 by 3 and get 126. Again, this is done through long division. 3 goes into 3 one time with nothing left over. 3 goes into 7 2 times with 1 left over, which gives us an 18. 3 goes into 18 6 times. Again, they write the answer as a sentence. Your average score is 126. Objective 3. Write properties of operations using variables. Here are two of the properties we've learned so far. One is the commutative property, A of addition, A plus B equals B plus A. Another one is the commutative property of multiplication, A times B equals B times 8. Notice you can write multiplication with the dot or nothing at all. Here we just have two letters written next to each other. If you have two letters written next to each other, you will also assume that is multiplication. The addition sign had to be written. When nothing is written, it is multiplication. These are just two of the many properties we've talked about so far. If you are uncertain about the other properties, please check your worksheets and notes from previous sections. Example, use the variable b to state this property. When any number is divided by 1, the result is the number. So we will use the letter b to represent any number. This is any number divided by 1 equals that number. And we've seen other examples of this, like 100 divided by 1 is 100, or negative 37 divided by 1 is negative 37. The b is standing in for any number. Objective 4. Use exponents with variables. Use exponents with variables. Recall, 3 times 3 times 3 times 3 times 3 can be written as 3 to the 5th. The 3 is used as a factor, so we call it the base. We use that factor 5 times, 1, 2, 3, 4, 5, so that is the exponent. This same rule applies even when we're using variables. So this, c times c times c times c times c, the c's we have are the factor, that's what's being multiplied, so that is our base. We are multiplying them 1, 2, 3, 4, 5 times, so that is our exponent. So the same rule applies whether you're using numbers or letters. Example, rewrite each expression without exponents. Y to the 6th. We have a y times itself 6 times. 1, 2, 3, 4, 5, 6. 12bc cubed. Be careful here. We have a single 12, we have a single b, and then the c is what is being cubed. C times c times c. The exponent only applies to the c. That exponent of 3 has nothing to do with the b and it has nothing to do with the 12. It is next to the c, so it only applies to the c. If there had been parentheses around this, we'd get a different answer. So be careful when combining exponents and parentheses. And if there are no parentheses, then the exponent only belongs to the thing it's next to. Negative 2 m squared n to the 4th. We have the negative 2 times m squared means we have 2 m's. N to the 4th means we have 1, 2, 3, 4 n's. So we have negative 2 times m times n times n times n times n times n. Another example. Evaluate x squared when x is negative 3. Recall that x squared means x times x. We are now going to replace each x with a negative 3. This x becomes a negative 3 and this x becomes a negative 3. Now we will multiply negative 3 times negative 3, and negative 3 times negative 3 is 9. Another example. Evaluate x cubed y when x is negative 4 and y is negative 10. Recall that x cubed y means you have 3 x's because of the cubed, and then a single y. We will replace the x with negative 4 and we'll replace the y with negative 10. So all 3 of these x's will become negative 4 and the y will become negative 10. Now we will multiply two factors at a time. Negative 4 times negative 4 is 16. That's a positive 16. 16 times negative 4 is a negative 64. And negative 64 times negative 10 is positive 640. That concludes section 2.1. Your next steps are to complete the worksheet for section 2.1. This is worksheet 9. If you are in my online class, you can immediately check the key for worksheet 9. Recall you have to check the key to get full credit for the worksheet part of participation. If you are in my face-to-face class, we will go over the key in class. Then complete the online homework for section 2.1 through my math lab. And then if you would like to, start on section 2.2 for next week.